Alright, welcome back. In this video we are going to continue adding code into our methods within our classes. In this video we're going to be focusing on the player class. So let's go ahead and jump over here to the player class real quick. As you guys can tell at this point, Hyperion's really starting to take shape. Now the player's got several different things that he can do. We've got moving, picking items up, dropping items, display, get current room, get inventory item, all of this stuff very critical for gameplay itself. So let's take just a minute and review what each of the methods are supposed to do, and then I'll have Logan start adding the code into the methods to make them, well, functional, actually able to do what we're describing them as being able to do. So starting out, move. This is the heart of the moving capability of the player. So what physically moves the player around in a level takes place inside of here. So when we call upon the player's move method, we're going to be sending it a string direction. We want it to move north, move east. It knows which way it wants to move. We're going to need to check to make sure that we can indeed move in that direction. And if we can, we need to physically move the player. Pick up item. Well, pick up items is an important one if you want your player to be able to pick up items. So we'll just simply call this method and we will send it the item name of what it is we would like to pick up. You know, it could be something like I want to pick up key or blue key. So I send blue key into pickup item, and we're going to need to make sure that the blue key does exist in the room that the player is currently in, and if it does, then we need to make sure that we take that item, the blue key, remove it from that room, add it to our player's inventory, and we're all good. Otherwise, if we didn't remove it from the room, we'd pick it up, put it in our inventory, and then if we said look again, well, there'd be a blue key on the floor still. So we could pick the blue key up again. Now we'd have two blue keys in our inventory and another blue key still sitting there. So we have to make sure that we can take the blue key out. Though, Logan, to be honest with you, in reality, I would love to have a room that did that with money.
I was just about to say, I'd love to have an error like that occur with my wallet. Wallet. All right, let's see, 1, 2, 3, 4, 5. There we go.
It just keeps adding. That would be fantastic. And, of course, with us having pickup item, we need to be able to drop item. And then, of course, we're going to tell it this is what we need to drop. So as long as we have that item in our inventory, it needs to remove it from our player's inventory and add the item back into the room's item list. Remember, we said that our player has a list for inventory items. The room has a list for our room items, and I described those as shelves way back in our planning video. So we need to simply add the item back into the room's list and remove it from the player's inventory. So moving on down here, we've got display inventory. This one here is really straightforward. All we need to do is, well, display the inventory. Simple enough. Basically everything that's within our list, let's write that out to the console for our player to see. Moving on down, we've got get current room, and you can see get current room actually has a return type of a room object, and the job of get current room is just that. Let's take a look at where the player's at and get that room so that we can use it for whatever, and there are several places we're going to need to call upon this. Moving down from there, we've got get inventory item, and you can see that it also has a return type for the method. It returns an item object back, and we take in a string parameter here, which is item name. So we're able to say get inventory item and give it a name like blue key, and then what's going to happen inside the method is we are going to simply look to our inventory list, our list of items on the player, and make sure that that item exists. If it does exist, we now can return that item back right here. Okay, so that's kind of a quick overview of what it is we need to add code in. So let's go and jump back up here to move, Logan, and this is, again, this is the heart of the actual moving. So let's go ahead and write this in.
Okay. When we're about to do a move, the first thing we need to do is to get the room that we're currently in, because we need to know if we can move out of that room in a specific direction.
That's right.
So I'm going to make a room variable called room, and I'm going to set that to whatever room the player is currently in. So I'll use players get current room method.
This is very important because in the next line we can now check, now that we have that room, we can check if the direction we want to go is a valid direction that exists within the list of directions or list of exits in that room.
Right, because if it's not, then we need to do something other than move. If it's not a valid exit, we have to tell the player that they can't exit in that direction and then not attempt to move.
Right.
So we'll do a check. We'll say that if not, so if we cannot ask or if we ask our room if we can exit, and we'll ask it in the direction. Again, we're being passed the direction to move, so we'll use that same direction down here and can exit. and then we'll block in the if statement. So if we cannot exit in the given direction, then what should we do? Well, we'll just display out a simple message saying that that's not a valid direction.
And as we know, every time we want to display something out to the console for our player to see, we'll just call upon text buffer and add to it what it is we want to have displayed. Invalid direction.
Alright, and that should take care of that. Now, because this was in fact an invalid direction, we want to make sure that we don't attempt to run any of the actual moving code. So from here, we're just going to return back out of the move method.
Right.
Now, if this came up true, if we can exit in that direction, now we need to go about doing whatever it is we need to do as our player moves. And the first thing that we need to do is record the fact that the player did move. So increment the number of moves that the player has taken.
And for those of you that are really new to this, this may look really confusing because Logan just said if the room can't exit, if that comes up to being true. Generally, the code that falls, let me come up here, the code that falls right underneath the if is generally the code that's executed if it's true. But he threw this not in here, so if it's not true. So it's one of those logic things which really kind of blows the minds of beginners. It's lots of fun there.
But if we did in fact get past that, we can move. Now we need to record this move. So we'll take our moves variable and we'll increment it. And now we need to move on to what was that you were going to do?
I was just going to throw in there real quick before we move on to the next section with moves. Again, just as a quick reminder, if we go ahead and move on back up here, you guys will recall that we had created a private static int that is called moves, and we set it to 0, and we had described earlier that the purpose of this is that every time the player physically moves through the level, we need to increment that number. Well, that's what this crazy plus plus is. And you guys have already seen this, too, when Logan was creating the for loops earlier. He would use x plus plus. Well, just real fast, let me jump over here and show you guys what that is. If you'll recall, when we did something like x plus equals 5, and the only reason I can get away with this is because I showed you guys that this right here is the same thing as saying, so this is basically saying x equals x plus 5, right? Well, if you see x plus plus, now this is the same thing as saying x equals x plus 1. Very common things. This one right here and this right here. Very common things you do in programming often. Take my current value and keep it and add to it something. Or take my current value and increment it by 1. Or decrement it by 1. Which, of course, if we came up here and we did x minus minus, this would be the same thing as saying x equals x minus 1. So, very fast way of incrementing and decrementing something. And if I jump back over here to Hyperion real quick, just wanted to point out, with moves, we're recording every time you move so that in our game rules section, if we wanted to have something, a game rule in place that said, let's see, if the player moves 5,000 times or greater, then we need to simply write out to the console, hey, you seem to be very lost, have no clue, and game is over. And at that point, we could have the game rules actually quit the game. So with the moves being recorded, we can now use that in-game rules to come up with something interesting. And in Hyperion, we actually do that. We only allow our player so many moves before we send in our SWAT team to take them out. So it just puts a little bit of extra pressure to make sure that we get the game completed as quickly as possible. Okay, so now that we've recorded that, it's time to actually move. We've checked to see if it was okay to move, and it's good to move. We've recorded that we have moved, so we've incremented that value. Now we need to physically move.
Alright, and with that move, we need to make a decision based on which direction we were fed, because if we were fed north, we're going to be moving our x and y in a different direction than if we were moving east.
Right.
So we'll begin a switch statement. We'll do a switch based on direction, and we'll block in the switch statement. And now we'll write in our first case. So we're doing a case based on direction. Now earlier we had done a case for what command was being used. And we had used a system where we just literally typed in a string. So if we were checking for north, we would have done something like case north as a string in quotes. But this time we want to avoid typing out the word north, in order to reference a direction, because we went and made the direction struct, which gives us a very convenient way of defining north as whatever we want it to be. So north could in fact be written as up if we decided.
Right.
Another thing that does is make it to where we don't have to type out the word north every single time throughout code.
Mm-hmm.
So where the case itself is going to be based on direction dot, as a matter of fact, capital direction, because I want to access the struct. So direction dot north. And that is, direction dot north is just a string variable. As a matter of fact, if I hold the mouse over it, you can see string direction dot north. So that is the same thing as typing north.
Right. Because that's been defined back in the struct for direction.
Exactly. So if this is in fact north, what do we need to do? Well, we need to take our player's position X and move it up. And up is...
and actually, I would change that to Y.
Right, I was just looking ahead. Y, we're using Y to represent up and down, as if you remember from the grid discussions we had earlier on the whiteboard. But we need to take our direction Y and decrement it, so we move up within the grid. And we also need to break out of the switch at this point, because if we moved up, then we're done moving, and we don't want to attempt to move in any other direction.
Mm-hmm.
Alright, now we can begin our second case. This will be if we have a case of direction dot south, then we need to move in the opposite direction, so position Y incremented by 1, and again, breaking out of the case statement at that point. Now we'll have a case for east, or rather, east. We'll have our direction dot east. In that case, we'll take our position X this time, and we'll increment it. And again, break out of the switch statement. And finally, we'll have a case for our west direction, in which we will take our position X and decrement it. And again, break out of the switch.
Now, breaking out of the switch is not the same as returning. It just gets us out of the switch. And we'll talk about that in more detail in a later video that's just about switch case.
Okay, so that's all we need for moving code. We don't need a default in this case, because we've already established from here that whether or not direction is a valid direction.
Right. Can I do a little whiteboard stuff here?
Sure.
Just in case anybody's confused as to, I want to move north, why are you decrementing Y? Or I want to move east, why are you incrementing X? Let's jump over here to the whiteboard real quick, and let's see. We have a whole bunch of stuff on, let me do this real quick. Actually, I'm going to switch over to a pen. I'm going to flip this around, and are you going to, real quickly, that'll work. Because I meant to actually be up here. We'll flip this back around. Now, let's draw this out. So I've got north, we've got south, we've got east, and we've got west. Now let's take a look at our code real quick. We had said that if we were going north, we were going to decrement Y. So if we go north, we're going to take Y, and we're going to subtract from it. Now, I just happen to remember if we were to go, if we were to go west, we're going to be decrementing X. So X is minus minus. And this leaves us where if we go the opposite way, it'll be plus plus, and down here, we're going to have plus plus. How did we come up with this? Because we could have flipped this if we wanted to. I mean, it's really up to how you code the engine. But here's what we did. Let's take our monitor, and let's look at our monitor. Then we're going to talk about a whole bunch of pixels for a second. The upper left-hand corner of our monitor would be 0, 0. Agreed? If we were going in this direction, the X direction, what way would X be going? It would be going in a positive direction, because if this location was 0, then X over here might be 300. So you can see that X has indeed gotten bigger. If we suddenly started going from 300 back this way, what would happen to our 300? It would be decrementing. And the same thing is going to apply to Y over here. Y starts off again at 0, and as we go down, which is south, what's going to happen to Y? Well, let's say down here somewhere we're at 300. So its number is incrementing. And from this we just simply said, well, all right, since obviously going in this direction is to the east, we'll just simply say that that's going to be x plus plus, so we'll increment x, which means for the opposite direction, which will be west, we'll simply decrement xx. And then let's take our y real quick. We said that just looking at our screen, the resolution, how it all works with pixels, if we're going down, what's going to be happening to y? Well, y is going to be getting bigger, so we'll just say that y gets incremented if we're going south, and if we're going north, we'll just do the opposite. So y is being decremented. That is where we came up with that, and then we simply apply that in code, because remember, with the player, here's our player running around, he has a position x and he has a position y, if I can write that out, right? And then so he has those two values that are being stored on the player at all times, and so all we're doing is incrementing or decrementing the number so that he's actually walking around. And it actually works out beautiful in our favor because it plugs right into the grid that we talked about earlier, and the way the grid is worked out with starting at column 0, then column 1, and then column 2, and then we, that's so there's your columns, and then of course having rows as well, starting at 0, 1, 2. So it all works out beautifully together. So I just kind of wanted to draw that out real quick, just so that you had an idea as to what was going on. So if your player was right here and he went up one, how we could simply take, so we just went north, right? And what is our y? It's a 1, and if we decrement our y, what does it become? 0. And so now he's up there in 0. So I just wanted to show that real quick. Maybe you'll find it interesting. Maybe you'll find it obvious. I don't know.
Right, and if you ever get confused on which direction you should be moving in X and Y based on north, south, east, and west, the easiest thing might just be to go back to that original whiteboard where we had the blue grid, where we were tracing out coordinate points. Just go to that grid, move in any of your directions, north, south, east, or west, and then look at that position, see what changed. Did X change? Did Y change? And if so, did it increment or decrement?
Exactly.
But with that now, we've got our switch statement finished, and we can move on to the final thing that we need to do inside of player. Now, after we've moved, we always want to show the room's description every time we move room by room.
Yeah, if I say north, I then want the computer to come back and say, you've now entered a dark dungeon, blah, blah, blah. I want feedback as a player of where did I just move into.
So after we move, we want this new room to describe itself. And the easiest way to access the new room would actually be through player. Tell player to run its get current room again, because of course we ran get current room up at the top when we first came in to move. But we'll run get current room again, and get current room is going to return a room where last time we stored that room in the room variable. Instead of storing it, since we're basically done and we just want the description, not the whole room, we can say dot after the get current room and tell it to describe. And that should be all we need to do. And again, this is kind of like how we had the look command working, where we had look access the player, get the current room, tell that to describe,
Precisely.
and we'll get the room's description.
Exactly.
All right, and with that takes care of our move. So I'll do a quick build, make sure that everything is still building, and it is.
Good.
And now we can move on to the next method.
Pick up item. All right, well, what does pick up item need to do? Well,
the first thing it needs to do is, again, check and see what room we're in, because we're going to be going through that room to see if it has an item that we want.
Okay.
So I'll begin with a room variable called room. We'll set that to be the player's current room, so get current room. And the next thing we need to do is define an item. We're going to see if there's an item in the room. So we'll define an item variable called item. We'll say that that is equal to room.get get item.
Get item, and we're going to send it the item name.
And now where is all this coming from?
Now, yeah, because this is where things get interesting now. So if we come over, so the room has a get item. So if we come over here to our rooms and we jump over here, describe title, get item, check this out. Get item sends an item back if the item exists. Remember, we walk through every item within the room, and if we find the item, we pull it out and we return the item. Now, it doesn't actually mean it removes it from that room. We just give up. There's the item. Or if it's not found, what do? We return null. That's very important here. So it's just basically we're returning empty. It's nothing, null. So keep that in mind, because now we're going to continue coding this, and you'll see how we can use that to our advantage to say, well, was there an item in the room or not?
Exactly. We need to check and see, because we gave in just a piece of text, a string, and we could have asked for an item that was not in the room.
Right.
And if it wasn't, that means that getItem is going to return a null, so we need to check for that null. So we'll begin this with an if. We'll say that if item does not equal null, we'll block this in. So if item does not equal null, that means we found that item within the room, and now we can do something with it. And I'll just jump down.
You don't want to put the inventory or the weight stuff in?
I'm just finishing off the if-else, because we do want something to happen. So we'll say otherwise. So if the item was null, we need to say that there's no item that can be picked up.
Okay.
So we'll write out to our text buffer. So we'll add some text, and we'll say that there is no, and then I'll break out of the string and concatenate to whatever item name was typed.
So let's say we said pick up blue key, and there was no blue key in the room. We'd end up down here with there is no blue key in this room.
Right, just give some message for saying that, yeah, we can't pick up the item because it's not there.
Right.
Now, if there was an item...
Now, we've got some inventory stuff. All right, this is where it gets a little bit more interesting. Because remember we said that we don't want the player to walk through the game level and be able to pick up every single thing they come across. And sure enough, when Terry tested it out, that's the first thing he tried to do. It's like, I'll just grab everything, and at some point I might need it. I can just go back to it, that way, because it'll be in my inventory. So what we decided to do was implement a weight system so that each item has a weight. And as you guys saw, we coded that in back in item, so it has a default weight of 1. And what happens is if you've tried to pick something up and that something is going to put you over your maximum capacity of what you are allowed to carry, which remember we defined that as 6, then it's going to tell you that you can't pick it up. Okay?
Alright, so this is the check we need to perform. We need to look at our current inventory weight, so player.inventory weight, and if that inventory weight plus the item that we're thinking of picking up, so if that item's weight plus our current weight is greater than our maximum weight, so our weight capacity.
You're on it. Yep.
And we'll block this in. And I guess while we're at it, we might as well put in an else in that as well. Actually, no, we don't need to do an else. We can do it all within, because if we can't pick up the item, we don't need to continue running any of the code, so we'll just return back out. So if we're over, or if this item weight would put us over our capacity, we need to tell the user that that's what would happen. So we'll grab our text buffer, we'll add to it, and say, you must first drop some weight before you can pick up this item. I'll say pick up that item.
Perfect.
And the line ran a little long, but that's okay.
Yeah, no big deal.
Back at the beginning. So, and if that was in fact the case, we will return at this point.
Yeah, we just simply return out of the pickup method altogether.
Which means that if we got past this weight check, that means that we had enough room in our weight capacity to add this item.
Mm-hmm.
So now we need to go about taking the item out of the room and putting it in our inventory. So we'll say we want to take the room, look into its, or take its items list, tell that list to remove an item, and the item that we want removed is whatever is held in item. Then we want to take our player, grab its inventory, actually it's inventory items.
Mm-hmm. You're at it.
And we'll add to inventory items our item that we're looking at. And then one last thing, after the pickup transaction has taken place, we want to show whatever was in the pickup text for that item.
And this again allows our level designer to put some specific text in with each item that gets displayed when the item's picked up. So if we picked up a PDA, it could say, after picking up the PDA, you looked at the screen noticing that there was a message flashing on it, and the message read. So again, just something for the level designer to use to put clues into the game.
All right. So with that, let's do a build test, and let's see. A few errors that we need to correct. First one is that inventory items is a field but used like a method. So inventory items, I didn't put the add after it. Inventory items is a list, which means it has an add method, but it is in of itself not a method.
Right.
So Hyperion.item does not contain a definition for pickup text. Let me actually jump over to item.
Nope. Put the U in. Right where you're at.
Oh, I see.
Nope. You were almost there. You were actually right on it. There you go.
Pickup text. Okay.
Now let's see what we get.
Then now it builds. So spelling will kill you every time.
Yep. That's just how it goes.
But all right, now the game builds again, and that means that pickup item is finished.
It's functional. Yep.
All right, we can move on to drop item.
All right.
Inside of drop item, we're going to begin yet again by getting the current room and storing it in a variable. So room equals player dot get current room. And let's see, we're going to hold an item again, so we'll have item stored in a variable called item. Now this time we're going to get the item that we're looking for is one held within our own inventory. So we're going to run get current or get inventory item, and then we're going to pass it whatever item or we're trying to look at. So item name, looking at it by name. And now we need to do a check, because get inventory item is going to look for the string held within item name. If it does find that item, it's going to return an item in the item variable. Otherwise,
and if it does not, it sends back null.
Right. So again, we need to do a check for null. So we need to say if item does not equal null, then we have found the item and can do something with it. Otherwise, we need to alert the player to the fact that they don't have that item in their inventory. So we need to tell the player, see, something like there is no, and then give the name that they typed. There is no item name, and let me space this out a little bit. I know it'll do it automatically later, but this will just make it look cleaner. So there is no item name in your inventory.
So if it was blue key and you didn't have a blue key in your inventory, it would read, there is no blue key in your inventory.
Alright, now if there was an item, and the item was not null, then we need to take that item out of the inventory and put it into the current room. So we'll take our player, we'll access its inventory items, and we'll remove from inventory items, and the item we're removing is, of course, stored in item.
Once again, we must remove that item. If we don't remove it from our inventory, we get into a reverse situation from what we described a little earlier when we were talking about we wished money worked that way in the real world with the rooms. If we had an item, like let's say a blue key, and we dropped the blue key in the room, and suddenly the room had a blue key in it, but we looked at our inventory and we forgot to take it out, well, we still have a blue key we could drop. So we could keep dropping blue keys all day long, and then that room would just magically contain lots of blue keys, and you would continue to generate them, so we don't want that.
Alright, so that's why we're taking it out of the inventory. Now after we remove it from the inventory, we need to put it into the room. So we'll grab the room's items list, and we'll add to it that item. And after we've taken the item out of the inventory and placed it in the room, now we need to give a message saying that that's what has happened. So we'll use our text buffer, we'll add to it and say the item, let's see, and then I'll do the concatenation thing again. The item name has been dropped into this room. Alright, looks good. And we'll do a build test, and everything is working good.
Very nice.
Now we can move on to display inventory. This is where we need to go through our inventory and generate a text message that contains something saying like, this is what your inventory contains, and then listing item by item. the first thing we need to do is start a few strings to hold the message that we're going to display, and then get ready to maybe underline that. Basically like what we had done for get item list back in room.
Right.
So we'll start our first string, which is going to be called message, and it is going to say your inventory contains, and then some stuff. So that'll be our message. We're going to have a string called items that will have the text representation of all the items that we have, starting out as blank because we haven't looked for items yet. And then finally we're going to have an underline to underline the title of the message. So I'll have a string underline. It will start out as a blank string so that we can turn around and use it to and have it pad itself for whatever length is in message. So say that underline is equal to underline dot pad left. We'll have it pad for however long message is, so we'll take messages length, and then we'll tell it to pad using the dash character. That should take care of our underline. Now we need to go through our inventory item by item and add the title of that item to our items string. So, well, as a matter of fact, we need to have the code be smart enough so that if there are items, it shows them, and if there are no items, then it gives a more valid message instead of there just being blank nothingness.
Right.
It actually says no items. So we'll do a check, and we'll see if our inventory items count is greater than 0. Because if it is, there's items we need to look for. If not, then we need to just say that there are no items. So that would mean the items display should hold something like maybe a new line, and then we'll put in pointy brackets, no items, like so. Now, if there were items, we have to loop through our list, item by item, to find them. So we'll do a for each, and so for each object of type item that we're going to store in an item variable in our inventory items list, we want to do something for each item. So we'll take our items string, we'll add on to it some text, beginning with a new line and an open square bracket. Then we're going to add on to that the title of the current item that we're looking at. So we'll ask item for its title. We'll take that title and we'll add on a closing square bracket. Now, after each item that we display, it'd be very useful if we would show how much that item weighed, so that when we review our inventory, we can see exactly why we're out of inventory space. So we'll add on to that another, as a matter of fact, let me go back inside and add some of this to the string. So after the square bracket, we'll add WT for weight, and then back out of the string where we will add on this item's weight. So we'll grab our item, show its weight. Now weight is going to be an integer, so we need to take that integer to a string before we display it. So we'll take weight dot toString, call the toString method, and then that can be appended onto the string itself.
Okay.
And that should be what we need for adding or accumulating text items inside of this items string. So that takes care of whether we have items or don't have items. Now we need to do something with the item string and displaying it. So we'll take items, and it would be, again, with the whole weight thing, it'd be helpful to also show the total weight of everything that we're carrying. So I'll take the items display text and add on to it again. And this time we'll add on some new lines, so 2 new line characters. And then we'll say that our total, wow, yeah, spelling there. There we go, spelling again.
It's all good.
I know. Alright, we have our total weight. And that total weight is going to be our player's current inventory weight. And let's see. We'll show that in relation to how much weight the player can hold. So when we show the weight, we want to show how much we're currently holding versus how much we can total.
Right.
So we'll add on another string, so we'll just add in a /. So plus /. And then we'll finally add on our weight capacity. So we'll grab our player's weight capacity. And that looks good there. Now we've got all of the text that we need to display held in items. Now we need to send that off to the text buffer. So we need to take our text buffer, add, and now we want to add the message, then a new line, then the underlying string that we had, and then all of our items. So we'll add, let's see, yeah, we want to add message, and then to that we'll have a new line, and then we'll add on our underline, and then we'll add our items. Excellent. Alright, that looks like everything, so we should be able to build, and there's no inventory weight, which is probably just another spelling thing.
It is. Yeah, you need an N in there. One more, yep.
And now if we build, then everything works.
Perfect.
Alright, that takes care of our display inventory. And that brings us down to get current room.
Okay.
I'm going to take out the temporary return that we had and replace it with the real value we want to return, which is the room that we're currently in. We can access the room we're currently in by looking at our rooms grid and plugging in our position X and position Y into that.
Right.
Now the rooms grid, of course, resides in level, so we need to access level, where we can get rooms. And now rooms is our two-dimensional array, so we'll do an opening square bracket. We'll feed in our current position X, and then our position Y.
And that's it.
And yeah, that's it. Looking up a room with our position should return a room object, which we can return out of this method.
All right, go ahead and build real quick.
So we'll build, everything is working. And now on to the last thing, our get inventory item. Again, I'll take out our temporary return so it can start looking through items. Now, get inventory item needs to take in the title of an item, look through all of our items one by one, and if it finds an item of that title, return that item object. So we'll start with a for each. So let's say for each item in the variable name item within our inventory items list. We want to go and look through and see if that item's name is equal to the typed name. So we'll say if item.title, actually it's capital case title, there we go. Yay,
just go ahead.
Fun.
Yeah, okay.
So if item.title, now we're going to compare these in a lowercase manner. So we want to add on to it to lower. So we'll have
whatever the title is, all converted to lowercase.
Exactly. If that is equal to whatever we typed, so item name dot to lower, then we'll return that item, because that means if this turns out to be true, that means we found an item of matching title. So we can return that item. And that will actually take care for everything we need to do inside of here. That means that if we find that, we'll return out, which means we stop looping and just return the item. Now, if we get out of this for each without returning, that means that no item matched the item name that we had typed. So we need to return null to indicate that there was no item returned.
Precisely.
Alright, now we can build. Everything is working. Now, while that takes care of all of our methods, there's one last thing that we need to look at.
Right.
And that is that inventory weight property. If we scroll all the way back up to our properties section, expand properties, then go to the last property we had, inventory weight, which we had marked as something we needed to do. We need to finish the weight calculation.
That's right. Now, if you guys recall, the way that we had demonstrated properties at first was that properties were basically associated with a variable. So if you addressed the property, then you'd end up getting or setting some value in that variable. But I had also said that properties can go beyond that. Properties can do pretty much anything. So we can actually have some code happen as opposed to having it interface with a variable. So here's a case where we're going to have a property that's going to execute some code when it's called upon as opposed to talk to a specific variable.
Right. So we can take out our note and our temporary return. Now we need to go and set up we need to look through items, item by item, and accumulate their weight. So we need to hold a variable that will be the total sum. And then once we get done adding to that, we need to return that sum back as the inventory weight.
Now, of course, we could have cached our inventory weight by just having a property for inventory weight that didn't go through and calculate things on the fly. But this is just another reason for us to, or another place for us to demonstrate being able to do something a little different.
Right. It also means we have to write fewer lines of code, because if we had a simple cached weight that we had, we'd have to mess with that every time we picked up or dropped items.
That's true too.
And in this case, since items themselves have weight, and we're not worried about performance too much in this case, we can just look through our items one by one and add up their weight.
Precisely.
So I'm going to make a variable called result to hold whatever we end up finding for our weight value. And I'm going to initialize that to 0. So in case there's no items, we'll return a weight of 0. Now we need to go through each item one by one, so we'll begin a for each. I'll say for each item in our inventory items. So there's our inventory items. And then we'll execute whatever we want to do for adding onto the weight.
So as we address each individual item within our inventory's items list, so that's every item in there, we're going to address each one at a time.
So we need to add that item's weight onto whatever we're storing in result. So we'll do result plus equals item dot weight.
Okay.
So that way every time we hit an item, we take its weight and add that to whatever is currently in result, which will in the end result in a total weight, which we want to return. So return result.
So now if I did something like int x equals player dot inventory weight, we can see that inventory weight returns an int, and inventory weight is, well, it does all this calculation and sends me that integer back.
So let's build, make sure that this is working, and it is. And that takes care of the method section. The only thing I want to do now is put a region around that, so that we can collapse it if we want for readability's sake. So put a region for our public methods. And then simply go to the bottom and end our region. Alright. So there we've got public methods for player, which we could collapse if we wanted. But that should take care of player. One last build to make sure that everything is still working.
All right, and you guys need to do the same thing. Just simply follow along. Hopefully by now maybe little bitty pieces are starting to make a little bit of sense. But if nothing's making sense, it's still okay. We still have a long ways to go. But follow along. Make sure you add all this code in. Watch very carefully. Make sure your symbols match Logan's symbols. And make sure your casing, uppercases and lowercases, match Logan's casing. And make sure you build after each area of code that you add into a method, so that everything resolves out just without problems by the end. And that's going to wrap up this video. Thanks a lot.